Hello, hello, dear attendees of WebNN. Let's start our session. And hello, everyone who is watching us online. Don't forget to send your questions in the chat. After the session, I will have a look if there are any. And let's talk today about privacy first, AI right in the browser. Let me make sure that no distractions. That is offline ready, future-proof, and based on the standards, also super important part of all the story. To start with, let me demonstrate very quick demo before we move on. And I will introduce myself right after the demo, but I want to catch your attention. What you see on that right-hand side of the screen is a very simple, absolutely static web front-end application that is intended to do one only task, to classify the image, to recognize what's on the image and give some predictions, estimations. And you see that it's like very technical one, so you can choose different models for doing this task. So you know that if we talk about AI, especially generative AI, every discussion starts first with the use case and second with which model do you want to use for this or that task. And there are like thousands of the models available for different purposes. Yeah, it's maybe not super clearly visible, but I will explain. You can choose which API in the browser you might want to use for doing this task to understand what's going on this picture, and a couple smaller kind of fine-tuned parameters for doing this task. And you see the image itself is pretty silly, auto-generated image of the plane. Intentionally, it's done by, let's say, first generation of text-to-image processors, far from being perfect. And of course, that brings a bit extra challenge to this demo to understand what's going on here. And you see that the demo itself, that the app itself is only half of the page. The second half is Task Manager from Windows, where you can see which devices are available, CPU, GPU, NPU, and which device is active during this or that moment of time. To save our time and to not deal with the logistics, this demo is pre-recorded, so this is just like a few seconds long video. But of course, the repo is available, and you can go and experiment with this yourself. But now, after this explanation, let me start this. So let's go for WebNN API in NPU mode. I'll explain later what this means. Classify, and yeah, we have some results. Let's see. So it considers this Wing 0.88 score, and 1 is the best possible score in that sense. Airliner to some extent, and some more exotic estimations like Tiger Shark, Warplane, Galeokedroquelia, I don't even know what's that, but I mean, it did its job after all, right? It at least recognized airliner. So with zero kind of playing with which model is the best, which parameters the best, in big picture that works. And it doesn't, the quality itself, definitely far from being perfect, but in this context, it doesn't matter. So we can find better model, we can find better parameters, better picture after all. What's important in this context is this spike. Actually, there are two spikes, to be honest. I don't know why the task was split into two subtasks, and maybe not clearly visible, but it shows us NPU, not CPU, not GPU. That means that for this classification, this web application used this particular piece of hardware that's included in this new generation of the laptops. It's Copilot plus PC. It's Microsoft Surface laptop 7th edition. To be honest, I'm a bit lost with our taxonomy of the devices. And this is very important. This is a big deal, and I'll explain through my session why is that. Finally, time to introduce myself. I hope that I got your full attention. I'm Maxim Salnikov. I'm based in Oslo, Norway, where I work at Microsoft, where I help developers to succeed with cloud technologies, developer tools, and AI. And I'm a developer myself. I build on web for web since late 90s of the previous century. I'm a huge fan of the developer communities and conferences and meetups. I present, I train, I organize myself. And what's super relevant for this particular gathering is I'm a proud member of Web Machine Learning Community Group, where we are doing our best to make sure that machine learning and artificial intelligence are first-class web citizens by incubating this or that API as a part of web standard. And yeah, I made this photo just a few minutes ago. I travel not alone this time with my baby Alexander. This is why I closely follow. I hope there will be no any kind of urgency calls from baby care in the hotel room, but just for you to know. And basically, this is third conference for 2 years, Alexander. And another fact to connect to our topic that I'm pretty sure when Alexander grows up, he will say that I was born the year when generative AI revolution happened, 2022. Like you remember this end of the year, ChatGPT was announced publicly. I mean, revolution at scale. Of course, it was available early, but maybe for limited number of people of job titles. But in 2022, yeah, it like huge blast happened, and still we are on hockey stick of adoption of all these cool things. Now, back to business. Let me list some facts that led to the need of having proper web APIs working with machine learning and AI technologies straight in the browser. First of all, research by Intel says that we love using web. And if you talk about our desktop laptop experience, we use our PCs for over like half of the time somewhere for web browser, maybe the lowest hanging fruit in that example. We actively use AI, not only building on and for AI, but use this. And it's like very conservative estimation says that over 1 billion people on our planet are doing something with artificial intelligence. And I don't know, I lost count on how many hundreds of millions of users are using ChatGPT as just one of the example. We have or will have really AI-capable devices. I mean, not just capable to run something, but with some specialized kind of hardware. This is super important. And yeah, maybe this is not mainstream yet. These devices like that laptop that contains very specific part of hardware to run AI and the machine learning workloads. But I'm pretty sure that this will become absolute mainstream in coming years. As users, we want best-in-class performance. We want all these returns, like responses, completions from our prompts as soon as possible. In best case situation, we want to keep it absolutely private. And for some cases and for some industries, this is absolutely must have. You have no chance to send any single byte of your prompt outside of your local device. And offline readiness, also nice point. Sometimes we are not connected. We are not always connected to internet. Actually, maybe it's a good idea to start thinking when you architect your next web application that being connected to internet, being online, this is kind of I don't want to call it edge case situation, but this could be plan A at least. If there is a chance, we want to have everything for free. Why to pay for provider of this or that large language model services if we can spin up something like on our local device? Now, put in the hat of developers. As developers, we prefer unified code base. In best case situation, it's write once, run everywhere, or at least as close to this as possible. And that means that we want to have some standards, right? Not to have our code different for different platform. And in that sense, web is perfect media for us to build the code. And also, not all of us in the room, starting from myself, are data scientists. And not all of us are machine learning engineers, AI engineers. I personally just develop applications, and I mainly focus on user experience, and this is my area of expertise. Still, I want to leverage all these latest and greatest AI technologies. That means that that would be great to have comfortable level of abstraction where we all confident in considering our technical expertise. So all these arrows brought us to the fact that we want to have native AI straight in the browser. We focus on web technologies. This is WebNN after all. And of course, standardized. We don't want to write new code for every new browser. This wish is very close to become true with the rise of web standard called Web Neural Network, or WebNN in short. Again, this is not something like proprietary from this or that vendor. You see on the screenshot, this is currently a draft for World Wide Web Consortium, W3C, and it covers exactly all these needs that I listed on my previous slide. First of all, performance. It provides near native execution. I mean, for sure, if we talk about propagating some capabilities from platform level, from this native code level to web stack, there is always some loss of performance, right? Just kind of overhead when we need to transit all these APIs to the browser. But in that case, it's around 90% of original native performance. This is quite good. Second, and this is a huge deal, it supports all possible, at least all existing to the moment, hardware on the device, CPU, GPU, and as you've seen on the demo, NPU, this special part of the hardware. I'll say a few words about that very soon. This is standard, so it's unified abstraction. So hopefully all browser vendors will accept this, will adopt this, will implement this. It knows nothing and doesn't want to know anything about the model. And there are pros and cons. To some extent, we have full flexibility, right? So we are not attached here to particular format of this machine learning models. So as flexible as possible. On the other hand, yeah, we need to implement all these nitty-gritty details how to run this execution ourselves, right? So we cannot rely on what model exposes us as the features. And also super important that this standard was not created in vacuum, was not created really from scratch. It considered all existing machine learning frameworks. Why? Just to make sure that this standard does not compete with them, but complement them. And you will see very soon what I mean exactly. And creation of this standard started not from, hey folks, we have cool tech, we have cool hardware, let's create some standard for that. No, it's wrong way, both for creating standard and creating solutions, creating applications. Don't try to find a problem for the solution. It started from identifying problems in the form of use cases. And basically a list of these use cases is part of this standard draft. So all this explicitly listed in the standard itself. That means that folks gathered real life pain points from the users, from the organizations, where running something AI related straight in the browser, straight on device could be a solution. Now let's talk about place of this WebNN standard in overall on device or edge AI ecosystem. And by saying edge, this is not about browser, this is not about Microsoft Edge. That means that about something on device itself, on laptop or mobile device, not something in the cloud. Bottommost layer, this is hardware. This is silicons doing this or that part of AI inference, AI workload. We'll say a few words about that very soon. On top of that, there is always some completely native layer. Native for this platform, Windows or Linux or Mac, native for either this is desktop or mobile platform. I mean, something that is software, but as close to the hardware as possible, considering a platform. On top of that, there is web stack, both on the backend, something with Node.js, and of course, browsers themselves. On top of that, we have set of standards. I mean, WebNN is not the only standard available these days for the browsers, for JavaScript ecosystem that is capable to run some AI workloads, but it's, let's say, the most, say, fine-tuned for doing exactly that job. But just for you to know, for sure, this is not the only way for you to build something. These web standards could be quite low level, and as a regular app developer like myself, maybe I'm not very comfortable by using what these standards expose directly, even though it's still about JavaScript, right? The objects, the methods they operate in could be not that comfortable for you, and I will illustrate this by example. This is why we have a set of higher level frameworks. So our best friends from JavaScript community created set of amazing libraries, and I will pitch one of them at the end of my session for us to pick our own level of, let's say, our own comfort zone, how exactly we want to build applications, starting from our technical deepness of everything. And everything starts, or in this particular case, stops in my narrative with use cases. You remember everything from the previous slide. Now, as I promised, few words about hardware. Why is that important to have multiple device supporting execution and solution for your task, for your problem? CPU, I mean, no device without CPUs for sure. It can do lots of things related to artificial intelligence, related to machine learning, but for sure this is not optimal piece of hardware to do this. In that sense, it's the fact that it's everywhere provides broadest compatibility, but don't expect best-in-class performance, that's for sure. Then graphics processing unit, or GPU. First of all, I don't think that it was invented for running AI workloads. The same, it was not invented for calculating blockchains. The name says it's graphics, right? But it turned out that the way it's architectured and implemented is perfect, not only for us to have, I don't know, hundreds of FPS while we game, but also for calculating blockchains and running AI workloads. So using GPU is all about throughput. So this is the most performant piece of hardware that you can use for that. In some cases, by performance, it competes with NPU. NPU, this is Neural Processing Unit, new kid on the block in this list, definitely the newest, the freshest, the latest. And as I mentioned, not all devices on the market today are equipped with this. Normally, this is not even like separate chip. This is part of CPU these days. At least this is how I understand this. And sometimes it's about performance, so it can maybe compete with GPU in some cases, but it's not the main advantage of NPU. Main advantage is power efficiency, especially if you talk about mobile devices like laptops, like mobile phones. We don't want to drain battery after running a couple of prompts, right? And this is where NPU jumps in. It provides best possible from these devices for sure, power management. So just to make sure that something can run in the background and do not drain battery too much. And after all, there is clear benefit of having NPU enabled device, just to make sure that you have separate silicon for calculating all AI workloads, while you can use all power of GPU for something else that you can run in parallel. I mean, this heterogeneous picture is the best in class, and main thing, third time that having NPU-enabled, NPU-equipped devices is slowly becoming mainstream. So maybe if you look at laptops available on the market, maybe majority of them are currently equipped with this NPU. Now, back to web neural network. What does it bring to us as users, as consumers of these applications created by maybe us themselves or other developers? We no longer depend on this network jumps, right? So, I mean, look at any AI-enabled software as a service solution or something similar. In many cases, vast majority of scenarios, it sends some API call to the cloud, right? First of all, it's availability of this cloud, like here. And second, it's always some overhead of networking. And we are not always online, as I mentioned. So when you architect your next web front-end application, have offline as a plan A, and luckily we have all amazing tools to provide offline first scenarios these days for years, like service workers, progressive web apps, etc. Then privacy. In many cases, we don't want to send any word of our prompt, any byte of our data outside of our device, and making sure that we are capable to do something useful, something meaningful straight on our device is always good. And after all, low cost. I mean, once we invested in the device itself, why do we need to pay for some cloud providers of these AI services and LLM services? Now we put head of developer or web developer, to be more precise, or even more precise, web front-end developer. Straight in our favorite stack, which is web stack, we can use all possible hardware. This is the only standard that exposes NPU. I mean, there is web GPU standard for running some AI workloads, but as the name says, it's purely about GPU. And to make sure that all devices are in the loop, WebNN is the only standard. It's well connected to native, completely native operating system services. It's very well connected with existing frameworks. Back to my statement that this standard was not created in full vacuum. It considers everything that was written before. And after all, this is standard, so it's consistent, efficient, and reliable experiences. Maybe time for me to explain how you can start experimenting as developers. First of all, yeah, it's currently mainly for people living on the edge. I'm not about Microsoft Edge, but in that case, exactly, because you can use this both in Microsoft Edge and Google Chrome, but I'm about latest dev versions. Canary or dev versions are supporting that. Maybe while I speak, part of this functionality landed somewhere in stable version. I mean, it's hard to follow, right? So version of my browser might be updated while I'm here on the stage. So, but to make sure that you are able to reach out to this standard, just install Canary or Dev version of either of these two browsers. And also, you need to enable Flag WebNN API. I hope that very soon this standard will go to trial, origin trial way, when you can test this more broadly with, I don't know, larger group of your potential visitors, customers, clients, you name them. Because, of course, Flag way to test this is not scalable, right? You don't want to explain every potential user that they need to, first of all, install latest version of the browser that is not obligatory stable and plus enable Flag. I mean, once this standard moves to origin trial, wow, this will be a huge leap for adoption. And couple more extra things if you want specifically enable NPU. So if this is like, if WebNN itself is cutting edge of today's technology, then enabling NPU is cutting edge of the cutting edge, because there are still some moving parts, not in the hardware, but how this hardware connected to web stack. So those you might want to, first of all, make sure that you run latest version of the operating system. I'm not sure, to be honest, that something except Windows is in scope these days, specifically for having NPU as a part of WebNN. And also, you might need to update drivers for your NPU motherboard. I don't even know, like in today's world, drivers for what? For CPU or motherboard or everything else? Just drivers from these vendors, Intel or ARM. But yeah, this is just technical steps, not a big deal at all. Now, just imagine that you enabled WebNPU. You are in the sandbox that says, okay, this standard is enabled and even NPU is enabled for you. You are ready to start coding, right? And as I mentioned, personally, I myself, not data scientist, I mean, I understand how machine learning works. I understand general construction of large language models, small language models, but I'm not really comfortable in writing code like that myself. Basically, this is building of execution graph where every node is this or that operation, and these nodes, of course, there are, I don't know how many thousands of them, are interconnected. And this standard works exactly on that level. I mean, it's still JavaScript, it's still available in the browser, you're super welcome to use this, but yeah, at least for me, this will take well, some time to understand how things work, some learning curve. But if you want to start building something immediately, you are absolutely covered, because you remember that I mentioned higher level frameworks available that still can leverage WebNN as their own backend. I mean, we still within web front-end only, so I'm not saying about backend in this session at all, but I mean, there are different levels of what is front-end and what is backend in this particular context. I mean, it's still something that runs exclusively in the browser, not anywhere on the server. But yeah, if we, in this particular diagram, we look at WebNN as the bottommost level layer of all technical stack. And of course, I mean, if you say that this WebNN is low level, someone who is coding with C, C++ will laugh at you, right? They will say, this is highest possible level I can ever imagine. This is JavaScript running somewhere in the browser. Low level, this is what I do, where I literally like operate with memory in CPU. But still, for our picture, we call this low level kind of backend. On top of this, there is a framework called Onyx Web Runtime. I'll explain what's that in a few seconds. I believe it's on my next slide. And also, I'll say a few words about Transformers.js framework that is operating exactly on my level of comfort, in my comfort zone, when I literally say, okay, this is the task, image classification, this is the model I want you to use. Just run this without ever looking at this execution graph or inference or any lower level things. And you choose your own level. I mean, it's all interconnected. Transformers use Onyx as backend for them. Onyx use WebNN as backend for them. So after all, somewhere like under the hood of web stack, we still leverage this standard if we wish, because you can choose other ones. But yeah, on higher level way. What is Onyx after all? Because like day one, when you start experimenting with web AI stack, something related to AI on the browsers, you will hear this name like 100%. Onyx itself, this is a format of the model, one of available formats, but it's very well spread. It's well known. It has lots of converters from and to Onyx. Maybe this is kind of mainstream standard how you build and ship and use models for AI inference these days. But this is just a format, right? Specification. Luckily, there is a whole thing called Onyx runtime. Basically, this is runtime that can operate with these models in Onyx format. Build them, fine-tune them, train them, use them, everything. And if you see what's on this picture, well, I can read aloud. It covers pretty much all possible platforms, at least mainstream ones. It has APIs for all mainstream programming language architectures, hardware. So this is very well tested, production ready, if I can say, enterprise grade set of runtimes, and you can easily find the one that works exactly for your device. But we are at the web conference, right? So this is why we are mainly interested in one particular part of this Onyx runtime called Onyx Runtime Web. This is how we can leverage all power of Onyx stack straight in the browser, straight using JavaScript. And as you see, in the options, when we set things up, we can choose multiple what's called providers in this context, and WebNN could be one of them. In addition to WebGPU, WebGL is like a predecessor of WebGPU, and the WebAssembly, this is for the most compatible way to do something because it leverages CPU. And okay, we can set WebNN as provider. What's next? How can we write something practical using using Onyx Runtime Web? First of all, that's absolutely possible. I mean, if you prefer staying on that level, you're super welcome. And here we operate not with execution graph, but with something like called inference session. And this is quite generic session of you doing something with AI. So it's definitely a higher level than execution graph, but still it's not task-based. So it's just generic session, and you need to provide all other parameters, supply all other code to do something. But at least we already locked format of the model, so we don't need to think how to work with this particular model. That's already good. If you don't want to stop here, Transformers.js. This is my personal choice, and this is what I used for building the demo I demonstrated at the very beginning. It's about highest possible level, at least so far, of us injecting some AI-enabled features in our web front-end applications. Supports NLP, natural language processing, supports things on like computer vision when you supply some image or video, and it can, for example, understand what's going on there. Audio, and even multi-modality, when you can supply both text and image, or maybe sound, or who knows what comes next, directly in the browser with task-based APIs. On top of that, we have access to a growing number of models that specifically can work with Transformers.js. And by the way, Transformers.js is now part of Hugging Face company. And that's really good, because Hugging Face, this is very trusted provider, vendor of and hoster of I don't know how many thousands of open source models, and thousands of them are in Onyx format that can be directly consumed by Transformers.js and WebNN as a backend for Transformers.js. So yeah, you can find all possible models on this website in their catalog. I mean, very specialized ones. For example, the best possible model for doing image classification, the best possible model for doing speech to text or text to speech or whatever, easily filterable, findable. And for sure, if you don't want to rely on open source model created by other folks, you can build your own one, convert it to Onyx, and supply it as a part of your application, and just point Transformers.js to your own model. And a really cool story about how Transformers.js constructed, it's the fact that once you pointed to some model as a part of this Hugging Face library, after the first download of the model, and I mean, let's be realistic, if we talk about some real world scenarios when we want to use this or that part of AI or generative AI, we need to download model that might be, let's say, from tens of megabytes to a few gigabytes, right? I mean, it's not really a blocker these days with broadband internet and 5G, and I mean, it's always improving, right? But still, of course, keep this in mind. So maybe you want to inform your users, your clients, your customers about, yeah, something will be downloaded, and you have control, you have full understanding what happens, and let these people take decision. But fact is, after you downloaded this, it's just seamlessly cached using cache storage API, the one actively used for by progressive web applications, by service worker API, and it stays in the browser. And again, as you as developer has full control on how you manage what was downloaded. Show me the code. This is how that looks. Compare this to building executional graph. Compare this to inference session. It's next level, right? Or I don't know, next order of magnitude in simplicity. So you literally create the pipeline. In this particular example, okay, I want to run sentiment analysis on this part of the text. You run this pipeline, you get something back. As simple as that. I mean, you explain task. Of course, I mean, there are some parameters you might want to provide. This is the simplest ever option without even saying which model we want to use. It as flexible as you need and as simple as you need, let's call it like this. And there are lots of these tasks available right now, right here, right today, and this list is only growing, and you see it covers pretty much all needed modalities. Now, let's sum up what I've just presented. Web standard for running artificial intelligence tasks are here. It's available. And this is the only standard that supports all hardware. So this is key differentiator from, for example, Web GPU that is with us for a few years. As this is emerging standard and still draft of the standard, there are still some moving parts. And it's a bit annoying, of course, right? Not what we want as developers, but yeah, living on the cutting edge of technology involves thinking about that. But actually, we know how to survive in this world, right? We have feature detection, we have progressive enhancement in our web front-end stack for years. With existing frameworks, as I mentioned, Onyx Runtime Web, Transformers.js, maybe a new cool framework was invented by some smart person while I'm here on the stage, available. So you can choose your own level of comfort. And these frameworks like Transformers.js also provide you with mechanisms for fallbacks. For example, for this particular user, WebNN is not available or NPU is not available. You can always organize fallback to GPU or CPU, something like that. But user experience first. Of course, let's not focus too much on technicalities. Let's focus on the fact that we provide best possible experience for our dear users of our applications. Keep them informed. I mean, if you need to download the model, you are. Tell them in advance that it will be downloaded and then stored and cached. If you want to provide any kind of fallback, for example, if this feature at whole, if web AI is not available on this device completely for some reason, you can organize fallback. I hard to call it fallback, maybe fall forward and redirect this prompt to the cloud. And for sure, you need to keep user informed and let them decide if it's good or not. Make sure that you not only cached the model itself that happens automatically if you use Transformers.js, but app itself, service worker, progressive web apps for solution, and all other normal tips and tricks how we delight our users with our applications. And this is the slide that I added just very recently, because completely new way for you to interact with AI features straight on the device is available now on at least two mainstream browsers, Google Chrome and Microsoft Edge. And this is still about you as developer build some web front-end applications that are capable to run some AI-related workflows like writing something, translating something, rewriting something, summarizing, all this, today it's kind of commodity, right? It was something high-level stuff just 2 years or 3 years ago, but now this is just, who can be surprised by that? And it also running something in the browser, but in a different way. So this is not about using WebNN or any other web standard from the ones I listed. This is basically a new breed, new generation of the standards. I don't think that this is part of like W3C draft yet. It's in incubation mode, but adoption by Google, adoption by Microsoft and respective browsers brings us to thoughts about, this will become standard for the web one day. And this is the case when, you still use JavaScript, you still use this high-level pipeline, like task-based APIs, and the code sample is on the next slide. But in this case, you don't care about the model itself, because model, you consider this as something built into the browser. And of course, like different browser vendors will provide different models. It's obvious. Like for example, Microsoft will ship 5.4, this small language model as a part of the browser, and Google will ship maybe Gem or something else. I mean, we don't care about that. We care about results, right? And care about the fact that it's still local, it's still JavaScript. And the code could look something like that. Again, it's very high level. You don't need to think about how things work under the hood for you. You don't need to think about the models. You just create object, for example, summarizer. You provide your prompt, you get result. You create object called writer, you provide prompt, you get result. As simple as that. Again, this is cutting edge of the technology, but you can start experimenting with that more or less immediately. Now, sharing some resources. For sure, like the app I demonstrated at the very beginning is available on GitHub, and basically there are two versions for Angular and for React plus Next.js. Basically, I use this framework like React or Angular mainly for UI level, for all these components. The code itself is very generic. You can use it without ever thinking about any high-level frameworks. But still, you might want to explore these demos, because I also created code samples, how you do feature detection. So maybe you noticed that not all APIs were like available in this list of APIs to choose from, and not all subcomponents of these APIs. This is why I have, it's because I have feature detection. If something is not available on this particular browser, on this particular device, it will be just like disabled, right? And the code is here. And of course, it's not only about caching the model, it's about caching application itself and make it installable. So Workbox as a best possible library for you to build progressive web applications is also in the loop in my demos. And this is my final slide, and this is my main call to action for you. This is linked to my LinkedIn profile, and maybe you want to take your mobile device, scan this, connect with me immediately. So you choose either connect or just follow. Why? To get this deck immediately, just message me on LinkedIn, send me the deck, and I will send you the link. If you personally on your team, on your company, want to get some support with WebNN or any other AI-related technology, I'm here to answer. And I post mainly about AI stuff, Gen AI stuff on the feed, so maybe you want to get stream of the news just by following me. And that's pretty much it from me. Dankeschön. Thank you very much. We have a couple of minutes for the questions, and I don't see any questions from online. So if you wish to ask something, just ask or come to me personally. Up to you. And I believe we have lunch break in a couple of minutes. Any questions you want to ask publicly in the room? No. Okay, no worries. Just come in person and let's have a chat. Thank you very much again.